All right, guys, last section here in chapter 9, which is on sequences and series. This is on geometric series. So, of course, a geometric series, just like a geometric sequence, is formed using multiplication as the pattern. And that means that it can also be division, okay? Dividing doesn't exist, okay? Dividing is just multiplying by a number that is between 0 and 1. So dividing by 2 is the same thing as multiplying by 1/2. Dividing by 3 is the same thing as multiplying by 1/3. Dividing by 4 is the same thing as multiplying by 1/4, okay? So a division counts as well. Again, we need there's going to be finite and infinite geometric series. We'll talk about both, okay? Right now we're going to talk about finite. Finite means, of course, that it stops. Infinite means that it goes on forever, okay? So let's first find the sum of a finite geometric series, okay? That goes like this. The sum of those n terms. So, and if you're summing 10 terms, it would be the s of 10. The sum of the first 10 terms, or whatever the number is equal to. This is, in the numerator, the first term times the quantity 1 minus r, which is the common ratio, of course. That's your pattern number to the n power, all over 1 minus r. Okay, so we can do a couple of those. Here's the first one. 3 plus 6 plus 12, ... plus 3072. Okay, so again, what we need to do, just like with arithmetic, is I need to know what term number this is. This is a of what? What term is this? I need to know that because that goes right here. That's the n number. Okay, so I need to write the explicit formula of this geometric series and then set it equal to 3072 to find out what term number this is. So here is the formula for an explicit geometric series. It is that the nth term of a is equal to the first term times r to the n minus 1 power. Okay, so what we've got is here a of n is equal to 3 times, we're multiplying by 2, of course, times 2 times 2 times 2 to the n minus 1. All right, so we want to set that equal to 3072. So 3072 equals 3 times 2 to the n minus 1 power. I need to get this thing by itself, so I'll divide by 3. Got my calculator over here to help me out a little bit. 1024 is equal to 2 to the n minus 1 power. Now, I need to cancel out this base of 2. This is why you have to learn logs, and before we do this, I have to cancel out this base of 2. In order to cancel out a base of 2, I log base 2 both sides. So, log base 2 of 1024 is equal to n minus 1. What is log base 2 of 1024? I can do it on this calculator so you can actually see me do it. Math, arrow up and get the log base. 2 of 1024 is 10. So 10 equals n minus 1. So I plus 1 and realize that 3072 is the 11th term. Okay, so let's find the sum of these 11 terms. What I do, let's follow my formula. I've got the first term, which is 3 times 1 minus 2 to the 11th power, because that's what term we just realized that 3070 is, over 1 minus 2. So here we go. I will use my I will use my alpha y equals button and type exactly what I see, which is 3 parenthesis 1 minus 2 to the 11th power, arrow down from there and close this off. And that's all over 1 minus 2. The sum is 6,141. Okay. Let's try another one. How about we have this here now? 4 plus 12 plus 36 plus dot, 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 972. All right, so here, we got to write the explicit formula, figure out what term this is. So I got that the nth term is equal to the first term times the common ratio, which of course is, in this case, 3, to the n minus 1 power. All right, let's figure out what term 972 is. 972 is equal to that explicit formula. I'll divide by 4. 972 divided by 4 is 243. I want to cancel out a base of 3, so I need to log base 3 both sides. Again, go up here to log base 3 of 243 is equal to 5. So 5 equals n minus 1. So that's the 6th term. All right, so the formula is the first term, 4, times 1 minus r, which is 3, to the n power, n is 6, all over 1 minus r, 1 minus 3. Again, I'll type that in. Alpha y equals 4, parenthesis 1, minus 3, to the 6th, all over 1 minus 3. And that sum is 1,456. Okay, let's talk about summing an infinite geometric series. Okay, well, first of all, let's do some common sense here. Okay, if I had, for instance, this. Okay, this is multiplying by 2, obviously. They're negative numbers. This is never going to stop. The sum of this is going to be negative infinity. It goes on forever. It keeps getting more negative. The numbers keep getting bigger. At some point, there's going to be a term that is negative infinity or close to it, right? We're going to get to an infinitely large number. Same thing like, let's say, with this. Again, I'm multiplying by 3. The numbers are getting bigger. I'm going to get to infinity. It's going to sum to infinity, okay? So the only time that you can sum, this is what's called diverging. Meaning that it's going away from 0. It's either going towards negative infinity or going towards positive infinity. You can only sum an infinite geometric series that is converging. Converging means that it is getting closer to 0. The series is approaching 0. Okay, so let me give you an example of that. That would be one like, say, sorry, I'm trying to find one. This 1/5, 1/25. I am multiplying there by 1/5 each time. I'm multiplying by 1/5 to keep going. Okay, now, what if you didn't know that? What if you didn't know that you're multiplying by 1/5? Here's a trick. If you ever want to know what the R is of a geometric series, you can take any term. Let's take the 1/25, okay? Take any term. Like I said, in this case, we're taking the 1/25 and divide it by the term that is before it. So I'm going to divide by, in this case, the term before 1/25, of course, is 1/5. Okay, whatever this equals is my R. Boom, 1/5. Okay, so this is getting closer to 0. The number's getting smaller, 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 right? 1 over, the denominator is getting bigger, it's getting smaller, smaller, smaller. The formula to sum a converging geometric series, the sum of an infinite geometric series that is converging, is very simple. It's the first term over 1 minus r. So the sum of this converging geometric series would be 1 over 1 minus r is 1/5. Okay, so let's type that in. Again, I like to use my alpha y equals button. 1 over 1 minus 1/5? And the answer is 5/4, or 1.25. Now, this is what's crazy about this. This whole series that goes on forever, getting smaller and smaller, at some point, the reason why this works, at some point, these numbers are going to be so small that they will not even contribute to the sum anymore. And how quickly does that happen? Well, this whole series adds to be 1.25, and its first term is worth 1. Which means that every term from number 2 on to infinity only adds to be 0.25. That's kind of mind-blowing to me. Heck, the first 2 terms add to be 1.2. So the remaining infinite amount of terms after the first 2 only add to be 0.05. Again, kind of amazing. Okay? Here's what you need for that. All right. I think that'll be good. All right. I'll see you tomorrow.